All right, good afternoon, everybody. Mark Sudduth here, another edition of Hurricane U. I want to introduce you to Andy Hazelton. I have cited many of his tweets throughout several of my Hurricane Outlook and discussion videos, and maybe even in a documentary episode or two. So I thought it was time that we sort of meet Andy over digital Zoom here because I've got a couple of questions for him. So joining me from South Florida, this is Andy Hazelton. Andy, introduce yourself, please. Tell us a little bit about who you are and why I find you important, because I certainly do, and I appreciate the very educational tweets that you put out.
Thank you. Yeah, so my name is Andy Hazelton. I work for the University of Miami and the Cooperative Institute for Marine and Atmospheric Studies, which works with the NOAA AOML, the Hurricane Research Division. So kind of work with both UM and NOAA on hurricane research. I do a lot of stuff with model analysis and development. I get to do some of the hurricane field program stuff as well. So just lots of work related to tropical meteorology and hurricanes.
Well, excellent. I appreciate you spending a few minutes with me here today and educating the group of folks that watch my videos. And specifically, I want to talk about two different terms here. One of them is TUTT, T-U-T-T, and
Right.
then just this idea of climatology. Why does climatology matter, and how does the TUTT fit into that? But first, I'll let you share your screen. Let's let you take it away. We see this term TUTT, T-U-T-T, all caps. It gets mentioned a lot in tweets regarding the season as a whole, what the models are seeing in the future. And even when there's a current storm or hurricane, people will say it's going to have to deal with King Tut. Now, we know that that is an old Steve Martin sketch on Saturday Night Live, for those of you old enough to remember that. But in the tropics, it means something entirely different. So tell me about King Tut, please, sir.
So yeah, for anyone who's followed the tropical weather, you're probably familiar with like the Bermuda High, the big ridge of high pressure centered near Bermuda that is over the Atlantic and steers storms and causes the trade winds. So this TUT, it's a similar feature. It's this upper level trough of basically like upper level low pressure that's sort of it's always there to some form or some extent or another. It's always there, just like the Bermuda High is always there in the tropical atmosphere. The difference is with the Bermuda High, we think of like a lower level thing, whereas this TUT, it's a feature that's up 300 or 400 millibars, 200 millibars, way up around the level where airplanes fly. And so if you look, this is from a paper from 1995 that sort of looked at, it was one of the first papers to sort of document this feature. So what you have is you have these streamlines. This is sort of an average, and we can talk a little bit later about what climatology and what that means. But basically, you have these streamlines of wind, showing that you have this trough in the average that exists in the Southwest Atlantic, and it extends into the Caribbean, and somewhat out into the Atlantic. Comes off of North America with this big ridge of high pressure, like we see over Texas, and this is, like I said, this is just an average. Sometimes it's stronger than usual, sometimes it's weaker than usual,
right.
And this is because what this does with the westerly or southwesterly winds here at upper levels. And then you have the trade winds out of the east. And so that difference is what gives you the wind shear, or that difference between wind between two levels that we talk about. So if this is stronger, if there's more, there's stronger westerly winds, you have more wind shear that tends to kill hurricanes. Whereas if this is a little bit weaker, that can lead to less wind shear and more hurricanes, stronger, so that's sort of what that is. But this, and it also, depending on where this is and how strong it is, that can also affect the steering of storms. So it's how this feature changes throughout the season is
Right.
important.
Right, it's important. So what do those four letters mean? TUTT. We'll start with the first letter. It is
tropical, upper,
right?
So the tropospheric trough.
Right. So it's in the tropics. That's very important. So when we say it's always there, is it there even in the off season, in the winter months?
Yeah, it's always, it's probably more pronounced in the summer, because that's where you have this big ridge of high pressure over North America. But you see it to some extent, I think in almost all seasons.
And so when we say upper tropospheric trough, again, you're talking about it's up in the middle. I'm sorry, the upper levels of the atmosphere, where you said like commercial aircraft would fly 200 bars up. So it's
right.
So it's not the same kind of a trough that gives us dry air and a cold front. Is it a different type of trough, so to speak?
It's got to, I mean, those upper level troughs, those cold fronts have upper level troughs, but this is different in that it's confined to those upper levels. You don't have like surface fronts with it. It's
Right.
almost solely an upper level feature.
Very interesting. All right. So the TUT is obviously an important factor. And you hinted upon it a little bit talking about the shear. So the basic question is, and let's just talk about this, why? Why is it an important factor? And specifically for on the negative side of tropical cyclone development, what can it do to sort of hinder development?
Yeah. So, I mean, if the TUT is, if it's strong enough, that basically means you have stronger winds out of the west here. And that leads to that stronger wind shear, the bigger difference in wind between the lower and upper levels. And that tends to tear hurricanes apart.
Right.
So like I have an example from the it's actually from the GFS forecast right now. So you can see this is 5 days in the future. So you see you have this big dome of high pressure over the southeast. That's why it's so hot. But then you have this TUT downstream, and right there it extends into the Caribbean. So you just have this wind, this wind out of the west around the
Sure.
trough, Bahamas. So with all that, as a result, you have shear that's above average in this region, and that basically just completely kills any kind of chances of tropical development.
Right.
Whereas if you go a little bit in the future, like if you go out to, I think, to like a little farther in this forecast, like day 8 or so, you can see it start that feature, that TUT, is starting to get a little bit weaker.
Right.
And it's doing what we call cutting off, where it can break into these smaller little pieces.
Upper
And
level.
sometimes
Yeah.
right, an upper level low. And sometimes when that happens, that weakens this, the shear gets a little bit lower. So like if you look a little bit further in the future, the shear in the Caribbean starts to get a little lower.
Right.
That's where those are the windows where you start to look for chances of tropical development.
Right. So it ebbs and flows. Does
right.
the weather pattern, it's interesting you talk about, and you showed the upper level high pressure there over Texas and the Southern Plains. Is there a relationship between how strong high pressure is over North America and then how strong the Bermuda Azores high are together, that couplet? Do those high pressure areas influence the TUT, or is the TUT sort of its own thing? As we kind of dig deeper into this, like what determines where the TUT is and how strong it can get?
Yeah, that's pretty complex. It's certainly the overall pattern over North America. When you have when you have a stronger ridge there, that can tend to force a bigger trough downstream. The other thing that can have a big influence is like El Nino or La Nina, because or even like some of the other oscillations about like the MJO, anything that changes the global distribution of heat and wind and where that sets up. So like during an El Nino, you have stronger upper level westerlies kind of across the Caribbean, across from the Pacific into this area, and that sort of makes the TUT stronger. Whereas like in a La Nina, you have stronger typically or weaker upper level westerly winds that come up out of the Pacific, and that sort of makes it weaker. So it's tied. It's sort of a it's its own thing in a sense, but it's also, you can't really disentangle it from the global weather pattern, if that makes sense.
Sure. And can you give me, if you can remember, any examples of storms, hurricanes, events where a particular system encountered the TUT and survived it afterwards and then went on to become a significant event, if anything pops out in your mind over history?
Yeah, a couple I could think of are Hurricane Andrew in 1992, where it ran into one of these. It was basically one of these. We call them upper level lows, or sometimes we hear them called TUT cells, because it's like where it's broke. So it encountered one of these, and it basically moved through it or under it, and in the process got sheared badly and basically fell apart for about a day or two. But then after it moved out on the other side of it, all of a sudden because on the west side of these, you actually have outflow. It can sort of take the air and move it away from the storm, which can lead to favorable. And Florence in 2018 kind of went through something similar a little further east. And so
go ahead.
The positioning matters.
Yeah, absolutely. And I was thinking back to 2005, what an active season that was. Katrina didn't really get started until the Northwest Bahamas. Rita didn't really get started until near the Florida Straits. Two very historic events. Can you remember back, did they not develop much because of the TUT? And I think Katrina was kind of the DNA of a couple of depressions or waves or something that didn't develop. We didn't have any big main development region hurricanes in that historic 2005 season that went on to hit the United States, where they cruised all the way across, like Ivan or Florence, for example. So if you can just recall, like 05 there, was the TUTT kind of responsible for not allowing Katrina to become Katrina before really reaching Florida?
I don't know the exact details of where it was. I'd have to go kind of create some plots to look at that. But I think from what I remember, it was because if you remember, but yeah, both Katrina and Rita sort of developed, like you said, in the Bahamas. And I remember with Katrina, I've looked at a lot of old satellite of that, and there was like one of these upper level lows or TUTT cells that sort of, because it was originally, I think, TD10 out in this area, and then sort of fell apart, and then sort of followed this upper level low. And over time, as that upper level low weakened enough, yeah, it just got into this big area of high pressure in the Gulf, and that's when it just blossomed. So yeah, I think it was sort of the positioning of that. The TUTT was such that stuff in the Bahamas, or east of the Bahamas, wasn't really favored, and that's why like you didn't have these long tracked. But then certainly in the Gulf, things are very different. So.
Absolutely. So I think it was last year that I believe it was you that pointed out on Twitter at some point that it looked like in the longer range, I think it might have been after Ida, somewhere around there, I don't remember, but somebody, and again, it may have been you, and if it wasn't, and you do remember who it was, that's great, because my memory is not perfect, but they noticed, maybe it was you, that the TUTT was going to set up looking at the long range guidance, and they were like, if this is there, it could be a real good shield for Florida, and that's basically what happened. I mean, what was it last year? Sam and
Larry,
Larry just never had a shot, because the steering and the unfavorable conditions. Do you remember that post? If it was not you, who did that?
I know I was involved in that discussion. I can't remember, how the thread started, but I know, there were several of us in that discussion because, we were showing, it looked like a lot of the seasonal and like the longer range guidance was showing this big, the TUTT, getting really strong east of Florida. And if you go back and look at like a plot from September, even though the shear in the Eastern Atlantic was really low, that there's this huge area of stronger shear east of Florida, such that everything just sort of either, we had a couple storms, I think it was Peter that kind of came up in here and just died. And then Sam and Larry were strong, but they turned well east. And so, that's something, being able to predict this, on a seasonal scale is kind of hard, but it's really important for, what storms in the sort of Southwest Atlantic do, which is critical for the Eastern seaboard. So.
Right. And so the TUTT itself wouldn't influence anything getting going in the Western Caribbean like Ida. I mean, the TUTT and Ida would have no relationship at all. Would that be a correct statement? Because the TUTT would be too far east of something like an Ida situation where the genesis is Northwest Caribbean and on into the Gulf of Mexico.
Yeah, for the most part. I mean, sometimes when stuff forms here in the Northwest Caribbean, you can have outflow into the TUTT because, if it's to the east, you can have the upper outflow actually helping the storm. But so typically in terms of negative, like the shear from in the Gulf comes from like troughs coming off the US and not the TUTT. But
that reminds me, let me interrupt you. So then Rita and maybe Katrina, I remember Stacy Stewart talking about that the upper level low east of Florida, and I'm paraphrasing here, was acting like a heat sink. Would that be an example of a TUTT low or the TUTT helping to ventilate and evacuate that air out of whichever one it was that he said that? Do you remember that discussion? That sat with me for a long time because it was a very technical but yet easy to understand way to see what was going on in the upper levels, that tropical upper tropospheric trough east of Florida was actually helping either Katrina or Rita, I think it was Katrina, to evacuate that air in mass. So the TUTT could actually help a hurricane if it's on the correct side of said TUTT. That's very interesting, Andy.
Yeah, so like if the TUTT is to the east of the storm, because in the northern hemisphere you have this sort of counterclockwise outflow. So if the TUTT's on the east side, it can actually help that air escape and the pressure lowers, the storm intensifies. It's when the TUTT is west of you, and you're moving toward it, that's when you typically see the westerly wind shear that weakens the storm. So that's, the positioning and the exact sort of co-location of these features is important.
Right. And that's hard to know 5, 10, 15 days out. That's why looking at deterministic models and even the ensembles to get those chess pieces exactly right is very difficult.
Right.
So let's move to climatology real quick. So how does this fit in? If it does, is there a way to kind of judge, well, in certain parts of the hurricane season, the TUTT is typically here. Is there an average position of the TUTT during different times of the year, or is it pretty random?
Yeah, so like this plot I showed originally was basically the average for July. So I mean, sorry, for August. So I think like July and August is typically where we think of like July or August or September is like the peak of hurricane season.
Right.
So as we go from August into September, I think this tends to weaken and then kind of re-strengthens as you get into the winter time and
Sure.
this jet stream comes south. So when I think of climatology, it's basically like an average over, typically a 30-year period is what we use.
Right.
And so it tells us like what is this average? What does it look like in a typical year? And one of the biggest things we like to do in meteorology is to take then a departure from average, like we call it anomaly, and it tells us like, are we more favorable than usual or less favorable? So like, these plots that I have from Tropical Tidbits, Levi's site, which has a lot of great
Yes.
stuff here. Yeah, so like you can see right here, this is all an anomaly. It's a departure from average, and that's what that tells us. Okay, it's more favorable than normal here, but then less favorable than normal here. And so climatology it's not really great as a forecast tool because almost never are things perfectly average, but how things depart from climatology tells you a lot about what the atmosphere is doing.
Sure. And so speaking of departures from the average, a lot has been said, and rightfully so, about sea surface temperature anomalies this year. And really the last several years, the Western Atlantic has been a lot warmer. So I'm just curious, do you know in your observations and research, do sea surface temperatures affect the TUTT? And intuitively, I would think not, because it is so high up, it's an upper tropospheric trough. But I'll let you answer it. Do the sea surface temperatures, or do we know enough yet? Maybe we don't, but do the sea surface temperatures, one way or the other, affect the strength and the positioning of the TUTT?
Yeah, I mean, maybe not directly like over the Atlantic so much, but it's certainly tied to how the sea surface temperatures and the anomalies, how unusually warm or cold it is, and how that affects like tropical convection, where where you get thunderstorm activity, where the air is rising. That does play a role.
Right. Yeah, and
So
everything, I
like,
guess you could say, is connected then one way or another.
right. So like the Pacific, if you have an El Nino and the Pacific is warm, you get a stronger TUTT typically. Right now we're in the opposite with La Nina. So it's
Right.
all, yeah, sort of linked together.
And so one last question regarding the TUTT, and then I'm going to let you go. Sometimes we see people bring up that typhoons in the Westpac can have downstream implications for maybe even messing with, for the lack of a better term, the TUTT. And there's that teleconnection, that interconnected globe of weather. The atmosphere is a fluid. We haven't had any typhoons that I can remember. When is the last West Pacific typhoon in 2022? I can't remember, maybe March or April.
Yeah, it's a long time.
Yeah, certainly nothing of any recent times, but we get into August or September, if there is a massive typhoon, very intense, and it recurves into the westerlies out there, instead of going straight west into China, let's say, can that have an influence, these West Pacific typhoons, on something as far away as the Southwest Atlantic's tropical upper tropospheric trough?
Yeah, it definitely can, because if it not every case does, but like you said, if it gets up in the westerlies, if it interacts with the jet stream, it creates this sort of we call it a wave train of basically like alternating ridges and troughs that extends from the Pacific over North America and all the way into the Atlantic. So like I think if you go back and look at Irma, that was a case where because of the typhoon, this alternating trough and ridge pattern set up in just the perfect way that you sort of had these, very favorable upper conditions over the storm, and also a ridge that sort of allowed it to go, all the way basically due west across the Atlantic for thousands of miles. And the other thing that happens with those typhoons is when they, it seems like from, research has shown that the models have a harder time predicting what's going to happen with these patterns, because there's a lot of complex interactions. So those are very tricky times when you've got these interacting features.
Well, that's all very interesting. I'm going to amend what I said when I said I had one last question. I'll amend it saying this is the last question.
Sure.
You talked about research and whatnot. Is there any research or aircraft recon in the vicinity of a TUTT. And I thought about that. I was like, if it's pretty important, does the Gulf Stream 4 sample the TUTT, for example, if on purpose or even just by accident, the way they drop the sondes out there in and around an approaching hurricane? Is there atmospheric active research being done in situ on these upper tropospheric troughs?
Yeah, so there is certainly when the G4 flies around the storm, it flies these large synoptic patterns, so it gets the TUTT and the ridge and everything in there. And I've had colleagues like Levi when he was here, he did some research on, I think at FSU actually, on like trough interactions and which ones are favorable versus which ones aren't. Michael Fisher, who's here at HRD now, has done some of that. So yeah, it's a very active area of research.
Very interesting. All right. Well, anything else you want to add before I let you go? I mean, we're in the latter part of June that we're putting this segment of Hurricane U together. Got a lot of hurricane season left. Climatologically speaking, we shouldn't have a very busy time right now, but there are some rumblings out there. Anything you want to add about that real quick before I let you go? Like, what would we look for with these two tropical waves, the TUTT, all that? Any kind of puzzle pieces that you can sort of comment on this early in the game? Or are we going to just say, nah, climatology is against it, forget it?
I wouldn't say totally rule it out, because the TUTT itself, I think in those forecasts I showed, the TUTT is going to be a little bit weaker than usual for this time of year. But the caveat on that is that it's still there. It's not gone like it might be in September. You still have some trade winds going through there. There's still some factors working against it. I think we'll have something to watch. It'll be a strong wave. Whether we get a storm out of it, I'm not sure yet, but we'll see.
Maybe some moisture. I got a good friend, one of our supporters down in St. John in the Virgin Islands. He said it is very dry down there, and he showed me a picture of his dashboard, and it's just, he wrote the word Sal on it. And it's all Saharan dust collecting on his car. He has to have the windows down when he works because it's so darn hot down there. So maybe at the very least, we don't want to wish a hurricane upon anybody, but they do bring beneficial rains, these tropical waves. And as long as it's not too much over too short a period of time, that could be a good thing. So maybe we can at least get that.
Let's hope. Yeah, looks like a lot of moisture. It's a pretty vigorous wave for this time of year. So,
all right. Well, Andy, I appreciate your time, and we all do. And good luck the rest of the season. It's probably going to be busy enough that you all down there at HRD and everything else related to that, we're all going to have our hands full once we get into the meat of the season, August through October. So thanks for spending some time, at least now, while it's fairly quiet.
No problem. Thank you.